Okay, so here is a force problem uh, using a traffic light. So I'll go ahead and read the problem. A traffic light weighing 2000 Newton is hanging in the diagram with the given angles. Calculate each tension. So before I move on to the problem, here are three laws that you need to know for Newton's laws of motion. So rule number one is inertia. Rule number two is the net force is equal to the mass times acceleration. And number three is there's always an action reaction force. Please keep this in mind when solving force problems, and I'll go ahead and get started. So first thing you want to do here is draw a free body diagram. So I'll first draw a free body diagram for the traffic light. So we have FG, and we have tension T3. And in this joint area, we have uh, T3 acting downwards, T1 here, and T2 here. Since these two lines, the dotted and the dashed line, are like parallel to each other, I know that this angle is 30 degrees, and this angle is 60 degrees. And this is 60 degrees. And we want to look in two directions for the net force. And because we don't want the traffic light to move, we want the traffic light to stay here, right? So the net force, sigma F, must equal to zero. And since there are two directions we need to analyze, I'm going to go ahead and first analyze the sum of the forces in the x component. So over here in this free body diagram, I need to break into two components, x and y. So you have T1 sine of 30 degrees here, and y is T1 sine of 30 degrees. Likewise for T2, I need to break this into x and y components. So we have T2 cosine of 60 degrees and T2 sine of 60 degrees. And then we'll go ahead and apply Newton's law, Newton's second law, excuse me. So, sigma F. So in the x direction, we don't have any like we need to sum up the forces, and that needs to equal to zero because I don't want the traffic light to move side to side. So it will be minus, since it's pointing in the minus x direction. So minus T1 cosine of 30 degrees plus T2 cosine of 60 degrees. With needs to equal to 0. And for the y direction, um, since both the T1 sine 30 and T2 sine 60 are pointing upwards, it's going to be a plus. So T1 sine of 30 plus T2 sine 60. And we have a T3 pointing downwards. So this needs to be a minus T3 here. And that needs to equal to 0. And over here, the free body diagram, the traffic light over here, the guy over here, we also need to write a equation for this. So since T3 is pointing upwards, I'm going to say T3 minus FG is equal to 0. We know FG is equal to 2000 newtons here because the problem says a traffic light weighs 2000 newtons. So we know that FG is 2000 newtons. So immediately we can determine what T3 is. Now we're solving two unknowns and we have two system of linear equations. Um, you can go ahead and use your calculator and solve that. And then you're gonna get T1 is equal to 1000 newtons and T2 you'll get 1732.05 newtons. And this is how you calculate each of the tension on the traffic light. Thanks for watching.